So in this last video in this series, we're going to talk about monopsony, which is a type of market structure where one firm has market power when buying an input, but doesn't have market power when selling its final product in the open market. So think of, as an example, a small company town. Okay? Suppose there's some town and there's only one employer in that town. This town makes some sort of widgets in that one firm. And so since there's only one firm in this town, and assuming that people don't want to leave this town, if they want to work, they're going to have to work for that one firm. And so, they either have to accept the wage offered by that firm or not work at all. We're then going to assume this firm subsequently makes this product and sells it globally on the open market, and that this firm has no market power when it's selling its final product. So it's producing a bunch of different things. But it does have market power in setting the wage. The more people it wants to hire, the more it has to pay. This goes against the assumptions that we normally make. We usually assume that there's a prevailing wage for a given type of worker, and firms can hire as much as they want at that wage. In this example, however, we're going to assume that the amount that they have to pay depends on how many workers they want to hire, or if they want to hire more workers, they have to pay a larger amount. Okay. We're going to then look at minimum wages using this monopsony theory. True or false, in monopsony markets, imposing a binding minimum wage can, in theory, increase the number of employees that a firm hires. So this is quite counterintuitive, but the answer is true. It is theoretically possible, if you have a monopsony market, that a correctly set minimum wage would actually encourage the firm to hire more workers. And I'm going to explain that now using an example. Okay, so we have John, Andy, Christy, Cindy, and Bob here, and we're going to assume that they each have a different reservation price. That is the lowest amount that they're willing to work for. We're also going to assume that that reservation price is private information. So they know what the reservation price is, but the firm doesn't know that. It only knows the distribution. It knows that one of them has a reservation price as low as $2. It does not know that the person who has that reservation price is John. We're going to assume that Andy has a reservation price of $4. Any wage below $4, he won't be willing to work. Any higher wage, he will be willing to work. Christy has a reservation wage of $6. Cindy has a reservation wage of $8. And Bob has a reservation wage of $10. And we're also going to assume that the marginal revenue product of labor, which is the additional amount of revenue that one unit of labor brings in, is going to be equal to $9. We can just say that each worker makes exactly 1 unit of output, and each unit of output sells for $9 in the world market. Okay, so now we're going to look at the number of workers they hire, or that they're trying to hire, the wage that they have to pay to get that number of workers. So we're going to have total expenditure in this column, and then marginal expenditure in this column, which again gives the total additional amount they have to pay to get another worker. Okay, so now let's suppose that these are the 5 workers in the market. The firm doesn't know which worker has a given reservation wage, but they know that one worker has a reservation wage $2, another of $4, another of $6, another of $8, another of $10, and so on. Okay? And we're also going to assume they have to pay all workers the same amount. So whatever number of workers they decide to hire, they all have to pay the same wage. So suppose that they want to hire one worker. How much would they have to pay this one worker to get him to be willing to work? Well, if they pay $1, none of these 5 people is willing to work. None of them are willing to work for a wage as low as $1. But if they were to raise that to $2, they would find one worker, John, willing to work. So let's say they want to hire one worker. Then the wage would have to be $2. The total expenditure would be the one worker times the $2, okay, which is equal to $2. Okay, what is the marginal expenditure in this example? Well, the marginal expenditure is the additional expenditure of hiring that additional worker. So if they hire no workers, the expenditure is 0. If they hire one worker, the total expenditure is 2. So the marginal expenditure is $2. Okay, now suppose that they decide instead that they'd rather hire 2 workers. Okay. What wage do they have to pay to get the next worker to be willing to work? $4. Right? They'd have to pay a wage of $4 to be willing to get John and Andy to both be willing to work. Okay, and we're going to assume that they have to pay them the same amount. Could be because they don't know which worker is willing to work for $2, and so to get 2 workers to respond to an ad, they have to offer a wage of $4. It could be that, if you pay people different amounts, people share the information with their coworkers, and one worker realizes he's doing the same job for less wage, that can make them really unhappy, so it can lead to a disgruntled workforce. There could be a variety of reasons. So we're going to assume they have to pay everyone the same. So if they want to hire 2 workers to be willing to get the second worker willing to work, they're going to have to pay a wage of $4, which means that the total expenditure is going to be the 2 workers times the $4 wage per each, which is equal to $8 in total that they're paying these workers. So what is the marginal expenditure? Well, the marginal expenditure is an increase in the amount that they're paying to all workers when they hire one more worker. It's not equal to the $4 that they're paying that next worker. Rather, you can see, since the total expenditure goes from $2 to $8, that the increase in expenditure is equal to $6. This $6 increase in expenditure incorporates the $4 that they're paying the next worker plus the $2 raise, essentially, that they're paying to John. Okay, now let's look at what happens when they hire a third worker. Okay, how much are they going to have to pay to get 3 workers to be willing to work? Well, to get Christy, the next lowest reservation wage person, to be willing to work, they'd have to pay $6. And so their total expenditure would be the 3 workers times the $6, or $18 in total. If you look at the expenditure, when they're hiring 2 workers, that was $8. When they're hiring 3 workers, it's $18. The difference, which is equal to the marginal expenditure, is $10. Again, which is higher than the wage that they're paying this marginal worker. Okay, if they want to hire 4 workers, they'd have to pay a wage of $8, leading to a total expenditure of $32, and that would imply that the marginal expenditure is $14, and so on. Okay, so let's look at this. How many workers would this firm hire when it's determining how many workers it hires by setting the wage? Well, if they hire the first worker, they earn $9 in revenue, but they have a $2 increase in their costs. Overall, they're still better off by hiring this worker, making $7 in profit by hiring this worker, so they would hire them. What about the second worker? The second worker brings in an additional $9 in revenue and costs an additional $6. Again, the firm would hire this worker. If you look at the third worker, however, hiring a third worker brings in $9, but increases the amount you're paying in labor fees to $10. So they're actually losing money by hiring this third worker, even though the wage that they're paying this third worker, $6, is less than the $9 that they're earning. Okay, the increase in expenditure reflects the fact that they are giving raises to the people who would be willing to work for less when they raise the wage to hire the third worker. Okay, so they would not be willing to hire this third worker. Okay, so now let's assume for a moment that there was a minimum wage that that they had to pay, and let's say that that minimum wage was set at $8. Okay, so just I'm going to erase some of this table. I want you to remember for now that that when there wasn't a minimum wage, the firm was willing to hire 2 workers, no more. Okay, now let's assume with a minimum wage of $8, what are all these amounts? Well, if the minimum wage is $8, even if they only want to hire one worker, they have to pay $8. Okay. Okay. And so the total expenditure is just the number of workers times $8, at least for the part that I've drawn so far. So it would be 8, 16, 24, and 32. What is the marginal expenditure? Well, the first worker, they go without any workers, they pay nothing in wages. If they hire that first worker, they pay $8, so the marginal expenditure is 8. Likewise, when they hire the second worker, the marginal expenditure is 8. The third worker, the marginal expenditure is 8. The fourth worker, the marginal expenditure is 8. Okay? For each of these workers, the revenue that this additional worker is bringing in exceeds the marginal expenditure on labor, and so they would actually be willing to hire each of these 4 workers. So I can actually erase this with the minimum wage that's set at $8. Rather than hiring 2 workers, they'd actually be willing to hire 4 workers. So this example here shows that the minimum wage actually increased the number of workers that this firm hired. Let's look at what would happen if they wanted to hire the 5th worker. Suppose that they offered to pay the minimum wage of $8. Would they be able to hire a 5th worker? Well, the answer is no, because they have 4 workers who have a reservation wage of $8 or less. To hire the 5th worker, they'd have to raise the wage to $10 to get Bob to be willing to work. So let's add that in here. So then what is the total expenditure? If they have to raise the wage to $10, now they're paying 5 workers $10 each. The total expenditure is $50, implying that the marginal expenditure is $50 minus $32. It's $18. Okay, so you see that they would not actually be willing to hire this 5th worker. But it still illustrates the fact that even though they aren't going to hire workers endlessly, they are willing to hire more workers, 4 with a minimum wage that's set at $8, rather than only 2 workers without any sort of a minimum wage. Okay, so this was a nice illustrative example. I want to now use a graphical example. Okay, so here I'm depicting what's happening in the monopsony market graphically. In that previous example, I assumed that every worker brought in an additional $9 in revenue for the firm. Usually we're actually going to assume that the marginal revenue product of labor is downward sloping. So each additional worker brings in a little less revenue than the last. One reason for this is there could be a diminishing marginal productivity of labor. Each worker makes a little bit less than the last. So even if they're selling each final unit of output for the same price, since each worker is a little less productive, each worker brings in a little bit less than the last. Okay. Now let's add the inverse supply curve of labor. So this is essentially the reservation wages of the marginal worker. So it starts out low. It starts out something like, let's say, $2, and the next worker is $4, and so on. We're going to assume that it's continuous, and you can hire fractional amounts of labor and so on. Okay, so what happens? We can draw the marginal expenditure function. Remember that the marginal revenue line in a monopoly market had twice the slope of the inverse demand curve. In a monopsony market, the marginal expenditure line is going to have twice the slope of the inverse supply curve of labor. Okay. And so it's going to intersect the demand curve or the marginal revenue product labor curve for the firm at some point, and that the horizontal distance of the intersection of marginal expenditure and the marginal revenue product of labor is going to give the amount of labor that this firm is going to hire without any sort of a minimum wage. Okay, and the wage they're going to pay is they're going to pay the lowest wage feasible to hire that number of workers, which is just the height of the inverse supply curve of labor that corresponds to that amount of labor. So it's this point right here. Okay. That's actually going to lead to a deadweight loss and inefficiency in this market because they actually are earning more if they were to hire another unit of labor than they'd have to pay that next worker. But they're not willing to hire them because the marginal expenditure, including any raises that they have to give to existing workers, exceeds the amount of revenue that they would earn. Okay, so that leads to this loss. So now let's look at what happens when they set an optimal minimum wage. And let's say that minimum wage is just equal to the height of the point where the inverse supply curve and the marginal revenue product of labor curve intersect. Okay, then at that point, if we set the optimal minimum wage at that point, each additional worker, at least for a while, is willing to work for the same amount. So they don't have to give anyone raises. They're paying the next worker the same amount, which is the minimum wage. The reason they don't have to give wages is because the minimum wage is actually making it so they're paying those people with low reservation wages a wage that is high enough to get the next worker to be willing to work. Okay, so for a while, the marginal expenditure is just equal to the minimum wage. Eventually, you run out of workers who are willing to work for the minimum wage, and at that point, the marginal expenditure jumps up. You have to pay enough to all your workers to be willing to get the next worker willing to work. That explains this jump. Okay, so looking at this, we can see that the additional revenue that a worker brings in is at least as great as the marginal expenditure with the minimum wage until this point where the inverse supply curve and the marginal revenue product of labor curve intersect, which is the sort of efficient amount of labor that you'd want to hire. Okay, so if the minimum wage is optimally set, you can actually increase the number of workers that a monopsony firm is willing to hire and actually reduce inefficiencies or actually completely eliminate inefficiencies in this market. So theoretically, minimum wages can be beneficial. Now, of course, if you set too high of a minimum wage, then the firm would be willing to hire very few workers, and so this would actually potentially create an even larger inefficiency in the market compared to the case with no minimum wage. So how well the minimum wage is set matters, and that is raising some interesting questions when a lot of cities and states are imposing a $15 minimum wage. Is that minimum wage too high? Fast food restaurants are thinking about replacing workers with machines, and raising the minimum wage to $15 an hour might expedite that change. So the last thing I want to do is to show you how you would calculate the number of workers that a firm would hire with equations. So far, I've only given sort of a rather specific example, which is not exactly in line with the mathematical solution methods that we've gone over in this class. Suppose that the supply of labor is given by the following equation, that the quantity of labor that's willing to work for some wage is equal to 2 times that wage. So if you pay a wage of $1, 2 workers are willing to work. You pay a wage of $2, 4 workers are willing to work, and so on. Okay? And my question for you is, how do you find the marginal expenditure function? The first thing we're going to do is we're going to write down the total expenditure function, which is equal to the wage times the quantity of labor hired. Okay, that's first. So we're actually going to plug in for the wage. So we can rearrange this this supply function to get the inverse supply function. We can get that the wage is equal to 1/2 times the quantity of labor hired. So that's the wage you need to pay to hire some amount QL of labor. And we can plug that in. So plugging that in for the wage, we get that the total expenditure is equal to 1/2 times the quantity of labor hired. So this part right here is just the wage times the quantity of labor hired, or simplifying, it's 1/2 times the quantity of labor hired squared. Okay. So now that we have the total expenditure, how do you think that we might get the marginal expenditure? Right, the rate of change in expenditure. If we want to get the rate of change in the total expenditure function, what do? We do what we always do. We take the derivative. So we get the marginal expenditure is equal to the derivative of the total expenditure function with respect to the quantity of labor hired. Okay, and that's just going to be equal to QL. Okay, so this is the marginal expenditure function. If you were trying to solve this problem, you would set marginal expenditure equal to the marginal revenue product of labor, also in terms of QL, and solve for QL, and solve. So it's sort of like setting marginal revenue equal to marginal cost. Here we're setting marginal expenditure equal to the marginal revenue product of labor. This wraps up our lecture on monopoly and monopsony markets. In the next lecture, we're going to look at price discrimination.